Pascal's triangle, and we're going to try to apply it to the binomial expansion. All right. Okay, so let's take a look. So it depends how your teachers might present this or the book that you have. So I'm going to try to, start it off, let's say, with 1 and a 1. Okay, and now what I'm going to do here is I'm going to create. Okay, so as I go along in here, okay, this is going to be a 1. Now, the entry that goes into here is going to be the addition of the 2 upper ones. Okay, so it's going to be 1 plus 1, which is 2. And then, so here I'm going to have another 1. So basically what I'm trying to do is, in Pascal's triangle, is I'm trying to look right above me and add the 2 numbers, okay, that are kind of side by side. So let's continue this. So next one will be, okay, so this is going to be another 1 because there's nothing else to add, okay, but in here, okay, I can add these 2, and if I add these 2, I'm going to get a 3. Now in here, I'm going to add these 2, and I'm going to get a 3, and then here there's only this 1 remaining. And so you notice that I can continue this pattern, and it's going to create this triangle for me. So Pascal kind of noticed this pattern as you can go through, and you can keep expanding it further and further. So I'm going to keep going here. So let's say this would have been a 1, right here. So the addition of those 2 is a 4. Addition of these 2 is a 6. And the addition of these 2 is another 4. And then that leaves me a 1. Okay, now, if I remove all of those fancy arrows there, so notice that it's going to start creating this pattern of that triangle. We don't really need them anymore because I think you get the gist of what we're doing. And you can continue this pattern all along. So now it's going to be 1, this is going to be a 5, this is a 10. Okay, so this is a 10. In here, this is a 5, and then this is a 1. And this continues on, so you can continue this pattern as long as you want. All right, so this is basically kind of, the first level. So level 1 in here, this would have been the second level, this would have been the third level, this would have been the fourth level, this would have been the fifth level, and again, so this would have continued on. And you can just keep going and going as far as you want. Now, where this becomes kind of useful is if you run into a binomial and you want to try to expand it. Now, so let's kind of recall. So binomial is basically 2 terms that you have, right? Bi, which means 2. So it kind of comes from the polynomials, right? Polynomials means many terms, binomial means 2 terms. And now if you want to start to expand, so I'm going to just try to show you. So we have, now it doesn't matter what those terms are. So I'm going to call them term 1, let's say plus term 2. So those are my 2 terms. And now if I want to deal with expansion. So let's say if I square this, then I know what to do, right? We can certainly expand that. You probably ran into that all the way in possibly grade 9 even, and definitely in grade 10. So here, what this will be is this is going to be term 1 squared plus, okay, then it's going to be 2 times term 1 multiplied by term 2 plus term 2 squared, right? So that's the expansion of that, which basically means t1 plus t2, and you expand it. So sometimes, you might notice, this being written out as x plus y. If you square it, then this would have been x squared plus 2xy plus y squared. Okay, so that's probably something more common to you. But I wanted to call them term 1 and term 2 because it doesn't have to be an x or a y. It can be any term that you like. Right? So it can be 2x, it can be 5y, it can be a z, it can be r, it can be just a number. All right? So I'm going to remove this out of the way and just stick to the terms. And this expansion, right? So if I would have went and now said, okay, what if I wanted to take the 2 terms and instead of just squaring it, what if I wanted to cube it? Okay? Now, what would happen? Now, it becomes a little annoying as that integer, okay, that exponent gets higher and higher. Because we can continue this and we can say, well, what if you wanted to take it to the power of 4? Or what if you wanted to take it to the power of 5? And so on. So obviously this expansion is going to become really annoying. And it's not difficult, it's just that you're going to have to go through the grind to do it, right? So for example, for this this one right here, if you worked this out, what you would have gotten is you would have gotten term 1, which now would have been cubed, plus you would have had 3 times term 1 squared times term 2 plus 3. Okay, this would have been term 1, and now term 2 would have been squared, plus finally you would have gotten term 2 squared. So that's how you would have expanded it. Now you might say, wow, how did he memorize that? Well, I didn't, because what I did was just above here, I actually have, and I see, okay, this Pascal's triangle, okay? And so I looked at this row and noticed that from this row, what I took was, I basically have the coefficients which are coinciding exactly with the expansion of that binomial, okay? So the coefficient in here, so we know it's 1, so notice 1. The coefficient here is 3, notice 3. The coefficient here is 3, so notice 3. And then the coefficient here is just a 1, and that's what we have in there. So it's pretty neat that this Pascal's triangle, okay, so this thing that he kind of created, this pyramid that just keeps growing, we can relate it back to whatever we want with a binomial expression. So if you want to square it, okay, notice if I go back 1, so if I go back into here, notice those coefficients go exactly with the level, and what I would have is, so this is my coefficient 1, so that's 1. This is 2, so that's your 2. And this is 1, and that's your 1. Now, the only thing that you have to kind of remember in the expansion is that the terms, notice that whatever you want to expand it by, so if it's squared, cubed, or even to the 4th, you have to know that each term that you will have is going to take on, okay, it's going to have an exponent. So for instance, if I go back to that third level, so basically the binomial expansion, which is cubed, okay, so this one right here, if I go back into here, notice what happens with the exponents. So what we do is we basically take the first term, all right, and because we are now cubing it, that is where our exponent comes in. So we're going to start with our first term, which is going to be the expansion, which is cubed. If it was squared, it would have started with squared. If it's to the 4th, it would have started to the 4th. All right? And now, next, okay, we keep decreasing it. So notice that it started with a 3. Now term 1 has a 2. And that means our term 2 comes in. And this really has a 1 there. And then now notice term 1 again keeps decreasing. It's a 1. And then term 2 keeps increasing, which is a 2. All right, and then eventually this one, and there you go, I caught my own mistake in here. So this should have been cubed, all right, okay, because it increased the second term. So this is great. So what we see is 3, 2, 1, and basically nothing in the last one. And term 2 goes in the opposite way, 3, 2, 1, and nothing in the first one. So let's try it. Okay, we're going to try to see if you can learn this pattern. Okay, so what we will have is this. So the coefficients are going to come from our Pascal's triangle. And then our terms, okay, are going to be actually in decreasing order, okay, as you keep going. So this is to the 4th. So what I will have is I'm going to have T1 to the 4th. Okay, so that's the first term. My coefficient is going to come straight from here, so that's a 1. All right. Now, there's no T2 in that first term. So now the second term, I'm going to leave a little bit of a space there, okay, because I know what the coefficient will be. Now, it's going to be term 1 cubed, and term 2 is going to come in, and that's going to be to the 1. My coefficient in front is going to be a 4. And now next, okay, so I'm going to continue. So now my coefficient is going to be a 6, and this is going to be term 1 is going to be squared, and term 2 is going to be squared. Okay, so it's term 2 is slowly starting to increase, and term 1 is slowly starting to decrease. And now again, notice my coefficient, so that is 4. And now here it's going to be term 1 is going to be just to the 1. Term 2 is going to be to the 3. And now my last one, I'm going to shift this just a little bit. Okay, so my last term is not going to have any term 1. It's going to be all term 2 to the 4th. And my coefficient is a 1. And you're done. All right? So we can apply this to anything. Now, if you've noticed and understood this pattern, great. Now, of course, you can keep going. You can make it to the 5th, so you can expand that. If you had to expand things to the 4th or to the 5th, and you did it just by brute force, by, you know, basically just multiplying them, expanding, and then multiplying, expanding, collecting like terms, it would take you a very long time. So I suggest kind of remember Pascal's triangle, and if any time a teacher asks you about trying to expand these binomials, you know, use that Pascal's triangle to apply it. Let's see it now on some actual binomial, because here I'm just calling it term 1 and term 2. Okay, so let's see how it would work. So here is kind of 2 examples that we have. We're going to take these examples and we're going to apply this exactly. So within here, so notice that what we have is, because we have to identify our term 1 and term 2. So my term 1 is going to be 2x. Okay, so that's going to be term 1 right here. And my term 2, all right, so term 2, because notice this is what it has to look like. Okay, now we're going to do it to the cube. So that means plus. So I'm going to suck in that negative, okay? And that's going to be my term 2, which is going to be just negative 2. And now I can go ahead and actually use Pascal's triangle. Now, from Pascal's triangle, so from the cubed, okay, so right here, so these are going to be my coefficients. Let me just copy, kind of bring it down, and I'll do it below here. All right, so those are the ones that I will have. No problem. So I'm going to start, okay, so term 1, which is going to be cubed. So what I'm going to do is I'm going to have to take term 1, I'm going to cube it. My coefficient is a 1, okay? So you don't need to put it in front, but you can if you like. Now, term 2, so it's going to be plus, okay? And my coefficient is a 3. And now what happens? My term 1 is going to be now squared, and term 2, which is negative 2, okay, is going to be to the 1. Now, and I will continue. So plus, now again, take the coefficient. So that's 3. And term 1, which is 2x. Now it decreases. So this is to the 1. And this is increasing. Now this is going to be to the 2. And finally, so plus the last one, coefficient is a 1. Okay, so I just won't write it because it's 1. And then my term 2 is going to be cubed. And there you have your expansion of this entire thing. Now, of course, I mean, we don't really leave it like this, so we would actually multiply the numbers and use the exponents and so on. And then we can collect it all, so it looks kind of nice and neat. So let me do that. So here, so the 3, so that means this is going to be 8x cubed plus, now let me take all the numbers. So 3, this is going to be 2 squared. Okay, so that's going to be 312, and then times 2, okay, is going to be 24. Notice the negative, so this is going to turn negative 24x squared. Now, the next one, so now let me just check if it's positive. Okay, it's going to be positive because that negative is squared right here. So now this is also going to be, so this is plus 3 times 2 times 4, and so that's again 24, except it's going to be x. And then finally, this is cubed, so it's going to be minus 8. And there you have it. So you have your expansion utilizing Pascal's triangle. So that's pretty cool, right, to have. Let's do one final one, okay, this one. And then you can take any terms you like and apply it to that. All right, so I'm going to just do this, okay, and proceed. So now this is to the 4th. All right, so we're going to use, okay, so if I go back to Pascal's triangle, I'm going to use this, okay, so that's the 4th order there. So copy, okay, bring it down, okay, so this is going to just guide me in terms of the coefficients that I'll have. All right, okay, so let's get started. So term 1, so this is my term 1, and this is going to be my term 2. It's already positive, so that's great. Okay, so that's what we have. So I always like to put the terms in brackets. Okay, and now I'm gonna go ahead and start. So this is gonna be to the fourth. Now next, so plus, so that one's done. This one is next, so this is gonna be coefficient 4. Term 1, 3x, so notice again it goes down, and your term 2 appears, okay, and this is only to the 1. So that's 1 out of the way. Okay, plus, so now this is 6, okay, and now term 1, so this goes, it's going to be squared, okay, because it keeps going down, and my second term starts to go up, so this is a 2. All right, plus, I'm going to run out of space here, so I'll kind of shift it out, okay, a little bit. So now next, so this is a 4, so I'm going to put a 4. My term 1, okay, again, keeps decreasing. My term 2 keeps increasing. And finally, last one, 5y to the 4. All right? And now indeed, so we would have to take each term, okay, apply the exponents to the actual numbers, okay, so 3 to the 4. So it would have started to get a little bit annoying, right? Because now we're going to have these bigger numbers. I mean, that's okay. 3 to the 4, I guess, what is that? 81. Okay, so we would have 81x to the 4. It's going to be plus, and now I can continue this. So it's going to be, let me just take this out in here just to make sure. So we have, so this is going to be 4 times 3 cubed, which is actually 27. So times 5. So this is going to be 540 xy plus, all right, and I think you get the idea. So I'm not going to torture myself. I mean, I guess you can expand it if you like. So that's how you can utilize Pascal's triangle, and it's pretty neat for binomial expansion. So it's a nice little trick that hopefully maybe in grade 11 one of your teachers will show you how to apply this, and let's see if you remember that trick. Okay, thanks for watching. Bye everybody.